Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you all are fine. I am Amina Sadiq, working as subject specialist in mathematics at Divisional Public School and College, Sahiwal. In our today's video, we are going to discuss about synethetic division. This is exercise 2.6 and the questions are 1, 2 and 3. Recalling the basic definitions, the first one is the polynomial in X. Let a0, a1, a2 and so on, an be the real numbers and n be a non-negative integer. Then polynomial is defined or expressed in the form an x raised to power n plus an minus 1 x raised to power n minus 1 plus so on plus a1x plus a0, where an should not be equal to 0 as an is the leading coefficient. A polynomial is usually expressed in the descending order of the exponents of the variable. The remainder theorem states that if a polynomial f of x is divided by x minus a, then the remainder is f of a, or we can write it as f of x is equal to the divisor x minus a, the quotient q of x, plus f of a, the remainder. Factor theorem states a polynomial f of x has a factor x minus a if and only if f of a is equal to 0, means the remainder is equal to 0. A real number a is said to be the 0 of the polynomial p of x if p of a is equal to 0 . The synethetic division is a method of dividing polynomials using the coefficient of the divided polynomial and its divisor. Let this be the divided polynomial and the divisor is x minus 2. Since the divided polynomial is in descending order, we can just use their coefficients. Synethetic division can only be used if the divisor is a linear factor. The linear factor means it is a polynomial of degree 1. The steps to explain synethetic division are: the first step is write down the coefficients of the dividend. For example, we have a cubic polynomial ax cubed plus bx squared plus cx plus d. We write its coefficients that are a, b, c and d. If there is a missing term, then we write its coefficient as 0. Then change the sign of the constant in the divisor. The divisor here is x minus k. The constant is minus k. Upon changing the sign, we get a positive k. Bring down the first coefficient of the dividend. The first coefficient of the dividend is a. We bring it down without any change in it. Then multiply, add and repeat. We multiply this a with k. It will become ka, add it in b and get a new term. This process continues until we get a remainder. The answer is the sequence of the coefficients of new polynomial. This is the sequence of new polynomial. This has 1 degree less than the original polynomial, and the last term represents the remainder. This is the flow diagram of the steps of synthetic division. First of all, we list the coefficients only, 2, -5, -1 and 3. Then, we use the root associated with the divisor or the constant term in the divisor. We put this root equal to 0 or put the divisor equal to 0, x plus 3 is equal to 0, then x is equal to -3, or we just change the sign from +3 to -3. Then we bring this 2 down without any change in it. Multiplying this 2 with -3, adding it in -5, we get -11. Again, multiplying this -3 with -11, we get +33, which is added in -1 and we get 32. Again, multiplying -3 with this 32, we get -96, which upon adding in 3, we get -93. Since this term is the last term, so this is the remainder. So the first term, 2, means 2x square minus 11x plus 32 gives us the quotient of the polynomial, and -93 is the remainder. We can write it as 2x square minus 11x plus 32 plus -93 over x plus 3. Now let's explain some questions related to synthetic division. This is question number 1, part 2. Use synthetic division to find the quotient and the remainder when 4x cubed minus 5x plus 15 is divided by x plus 3. First, take the constant term of the divisor with the opposite sign and write it to the left. The +3 and the divisor will become -3, and we write it on the entire left side. Then we write the coefficients of the dividend to right side with the missing term written with 0 coefficients. The coefficient of x cubed is 4, the coefficient of x square is 0 since this is the missing term. The coefficient of x raised to power 1 is -5, and the coefficient of x raised to power 0 or the constant term is 15. The first step is we write the first coefficient as it is, or we bring down the first coefficient without any change in it. The second step is we multiply the left part of the table by the last entry in the result row. Means we multiply this -3 with 4, we get -12. This -12 is added in 0, we get -12. The next step, we multiply this -12 with -3 and get 36. This 36 when added and -5 we get 31. Similarly, we multiply 31 with -3 and get -93, which when added in 15 we get -78. Since this is the last term, so we completed the table and obtained the following results. We have 4, -12, 31 and -78. These are the coefficients of the new quotient 4, -12 and 31, while -78 is the remainder. So we can write the quotient as 4x square minus 12x plus 31, and the remainder is -78. Now we have question number 2. This is part 1. We have to find the value of h by using synthetic division. If 3 is the 0 of the polynomial, 2x cubed minus 3h x square plus 9. Since 3 is the 0 of the polynomial, it means the remainder should equal to 0. Writing the coefficients of given polynomial, that is, the coefficient of x cubed is 2, the coefficient of x square is minus 3h, the coefficient of x is 0, it is the missing term, and the constant term or the coefficient of x raised to power 0 is 9. We divide it by 3. As 3 is the 0 of the polynomial, we do not need to change the sign of it. Bringing 2 down without any change in it and multiplying it with 3, we get 6. Adding 6 and minus 3h, we get 6 minus 3h. Multiplying this 6 minus 3h with 3, we get 18 minus 9h. Adding 18 minus 9h with 0, we get 18 minus 9h. 18 minus 9h when multiplied with 3, we get 54 minus 27h. Adding 9 in it, we get 63 minus 27h. Since it is the remainder, but we have already discussed that the remainder is equal to 0. So, 63 minus 27h is equal to 0. On solving it for the value of h, we get 7 over 3. Now for the question number 3, we are considering the first part, use synthetic division to find the values of L and M if x plus 3 and x minus 2 are the factors of the polynomial x cubed plus 4x square plus 12x plus m. As the two factors are given for this polynomial, we change the sign of the constant term and get minus 3 and positive 2. Since minus 3 and positive 2 are the zeros of the factor of the given polynomial, since minus 3 and 2 are the zero or the factors of the given polynomial, so their remainder should equal to 0. The coefficient of x cube is 1, the coefficient of x square is 4, the coefficient of x raised to power 1 is 2l, and the coefficient of x raised to power 0 or the constant term is m. On the first step, we will divide it by first factor, that is minus 3. Minus 3 when multiplied with 1, we get minus 3. On adding it in 4, we get 1. Again multiplying 1 with minus 3, we get minus 3. Adding it in 2l, we get 2l minus 3. Multiplying this 2l minus 3 with minus 3, we get minus 6l plus 9. Adding it in m, we get minus 6l plus m plus 9 equal to 0. This is equal to 0 because the remainder is equal to 0. We call this equation 1. The second factor is 2, so we divide the same polynomial with 2. This 1 brings down as it is and multiplied with 2, we get 2. This 2 when added in 4, we get 6. This 6 when multiplied with 2, we get 12. This 12 when added in 2l, we get 2l plus 12. This 2l plus 12 when multiplied with 2, we get 4l plus 24, which when added in m, we get 4l plus m plus 24 equal to 0. This is again equal to 0 because we know that the remainder should equal to 0. We name this equation 2. Subtracting equation 1 and 2, we get minus 10l minus 15 equal to 0. Solving it for the value of L, we get L is equal to minus 3 over 2. Now, putting this value of L in equation 1, we get minus 6 times minus 3 over 2 plus m plus 9 equal to 0. Solving this for the value of m, we get m is equal to minus 18. So, the value of L is minus 3 over 2 and m is minus 18. Let's recapitulate our today's demonstration. In our today's video, we discuss about the synthetic division. The process of synthetic division is explained step by step. First of all, we put the divisor equal to 0 or change the sign of the constant term. In this example, we have the divisor x plus 3. So we divide the coefficients of the given polynomial by minus 3. The coefficients of the given polynomial are 1, 7, 10 and minus 6. Since there is no missing term, so we do not put any coefficient equal to 0. We bring the first coefficient down without any change in it. Multiplying this 1 with minus 3, we get minus 3. Adding this minus 3 in 7, we get positive 4. 4 when multiplied with minus 3, we get minus 12, which when added in 10, we get minus 2. This minus 2 when multiplied with minus 3, we get a positive 6, which when added in a negative 6, we get 0. This remainder equal to 0 means minus 3 is the factor of the given polynomial, or we can say that this divisor divides the polynomial exactly. These terms 1, 4 and minus 2 makes the quotient, and this quotient has 1 degree less than the given polynomial. So the quotient is x raised to the power 2 plus 4x minus 2, and the remainder is 0. For using synthetic division, we should keep 2 points in mind. First, the exponent of the variable in the divisor should equal to 1, means the divisor is a linear polynomial. And the coefficient of x should also be 1. There is another example of synthetic division. X cubed minus 11x plus 14 is divided by x minus 2. First of all, we write the coefficients of variables in the given polynomial or the dividend. The coefficient of x cubed is 1. X square is the missing term. We replace it by 0. The coefficient of x is minus 11 and the constant term is 14. We have to divide it by positive 2 on changing the sign of the constant term in the divisor. We bring down 1 as it is. Multiplying 2 with this 1, we get 2. Adding 2 and 0, we get 2. Multiplying 2 with this 2, we get 4. Adding this 4 and minus 11, we get minus 7. Multiplying this minus 7 with 2, we get minus 14. Minus 14, when added in positive 14, we get 0. So the remainder is equal to 0. This means that 2 is the root of the given polynomial. We write the given polynomial as the multiple of divisor and the quotient. We can obtain this quotient from these terms. 1 is the coefficient of x square, 2 is the coefficient of x, and minus 7 is the coefficient of x raised to the power 0 or the constant term. This quotient should be 1 degree less than the given polynomial. So 1 is the coefficient of x square. Again, the synthetic division can only be used if the divisor is a linear factor. If we want to divide a polynomial, the coefficients of the polynomials are written in the descending order of the exponents of the variable, and we change the sign of the constant term in the divisor. The last term give us the remainder. All the other terms gives us the coefficients of all the other terms give us the coefficients of the quotient, and this quotient is 1 degree less than the given polynomial. If the polynomial is cubic, then the quotient is quadratic. If the polynomial is quadratic, the quotient is linear. Let's have another example. 2x cubed plus 6x squared plus 29 is divided by x plus 4. The coefficients of x cubed. The coefficient of x cubed is 2. The coefficient of x squared is 6. The coefficient of x is 0 since it is the missing term, and the constant term is 29. Changing the sign of the constant term in the divisor, we get minus 4. We bring 2 down without any change in it. Multiplying with this 2 by minus 4, we get minus 8. When minus 8 is added in 6, we get minus 2. When this minus 2 is multiplied with minus 4, we get positive 8. When this positive 8 is added in 0, we get 8. When this 8 is multiplied with minus 4, we get minus 32. When this minus 32 is added in 29, we get minus 3. If the remainder is other than 0, it means the divisor is not the factor of the polynomial. The coefficients of the quotient is 2, minus 2 and 8. Since the quotient is 1 degree less than the given polynomial, so this is the coefficient of x squared, minus 2 is the coefficient of x, and 8 is the constant term. We can write it as the quotient plus remainder over divisor. Now, it is the time for your home task. Please watch the video carefully and complete the remaining parts of the question number 1, 2 and 3 of exercise 2.6. Also, solve the related examples. My dear students, synthetic division is an easy and a shortcut method to find the quotients and the remainder when the polynomials are divided by the linear divisors. I hope our today's video helps you in understanding and solving the problems related to the synthetic division. That's all from our today's lecture. Stay safe, stay calm. Thank you and Allah Hafiz.